And thanks very much for giving myself and Kieran the opportunity to talk a little bit more about the Dingle Project. And actually, this is a historic day. So it's exactly 1 year ago today that our technical trials finished. So quite a bit has happened since then. But when we spoke to you last, it was in October 2022. And we were really at the early stages of our flexibility trial at that point in time. And Kieran will be bringing you through exactly what that involved and the detail of that. But just to give you a quick overview of what we're going to talk to you this evening about, for those who were on the previous session with us in October 22, apologies if we go over some old ground, but we want to just provide an introduction to what the project was about, what its objectives were, and then we have a number of technical areas. For example, Kieran will talk about the work that we did to improve the electrical network in terms of making it more reliable for people that would be transitioning towards low carbon. I'll talk a little bit about the active energy citizen and what that was all about. And then Kieran will take us through the customer flexibility trial and our EV trial. And then I'll talk a little bit about the reports that we produced. And in case we don't talk about some of the learnings earlier on, we'll try and mop up some of them later on. And then we'll have the Q&A that's open to everybody. So hopefully you'll all have some good questions. So the project kick-started in 2018, but it was actually conceived in 2017. And then by the time we got it kicked off was 2018. But, we were promising lots of things to lots of people at that stage. So we had to refine our scope in 2019, basically to basically align with what we could actually achieve over the period. But it was a 3-year project, essentially. It was impacted a little bit by COVID, and that's why our technical trials were kind of pushed into the start of 2022. And really what we were trying to do was figure out whether or not the network could cope with the electrification of heat and transport, but for us to learn a little bit in one part of the network in terms of what the impacts might be. And I suppose we were all doing that. We were doing this even before the government had designed or published its climate action plan. We were glad to see that over the trajectory of the project, what we were doing was aligning with government policy. So the Dingle Project area, that's really where we wanted to trial everything. And we were working with a really good community there. And I'll talk a bit more about that in a minute. And over on the right-hand side of the slide there, you can see the 4 objectives of the project. So one was obviously, as I touched on earlier, increasing reliability of the network. So with more and more people transitioning to low carbon technologies, we obviously wanted to make sure that the network was reliable enough to cater to their needs. And, if there were faults and things which happen from time to time, were we able to test and trial various technologies to minimize the instances of faults, or if they did occur, to help us actually pinpoint where they happened to get people to them to solve them. So Kieran will talk a little bit about that. And kind of one of the things that was kind of been discussed at length kind of around the time the trial started was the concept of peer-to-peer. If you had excess solar power being produced from your solar panels, you didn't need it, could you trade it with somebody in your community? So we intended to design a peer-to-peer trading mechanism, or to test it out and trial something. But unfortunately, we had to de-scope that later on because we were dependent on having one of the electricity suppliers to work with us in that regard. And due to a combination of circumstances, it didn't actually suit some of them to actually, or any of them to participate fully with us. So we had to actually take that out of scope at that time. But look, we had some learnings in terms of how we engage with people and the scope of what we were actually trying to do. And we published a report on that. The third objective was then around customer flexibility. And really we were trying to see whether or not it was technically possible to control technologies in the trial participants' homes, to use them in a way or operate them in a way that they could offer services or support to the local electricity network. And Kieran did a very detailed trial on that, and he'll share all the learnings from that. And the fourth area then was the active energy citizen. And what we meant by an active energy citizen was somebody who, through their actions and decisions, they could actually pay a positive impact on the electricity network in terms of how they use energy. And we did lots of work in that space, and we'll share those learnings with you now in a few minutes. So next slide, Kieran. So I suppose you might say, why did we choose Dingle? And I suppose one of the reasons we chose it, well, it was an exposed part of the network. And really what we wanted to do on the one hand was figure out if technologies we deployed in Dingle could survive there, well, then they'd probably survive anywhere on the electricity network across the country. But the other reason was we were well aware that there was lots of initiatives happening across the Dingle Peninsula in the wider sustainability area. People were motivated around the low carbon agenda, and we felt that by actually initiating our trial there, we'd find lots of willing people to actually work with us. So they were the kind of the key reasons for choosing Dingle. And really, we set off early on and we decided we needed people to work with us. So we found a number of different cohorts of people across the peninsula, and we engaged directly with them. So one of the first things we did is we identified 5 ambassadors, and people that were representative of different parts of the community. We had a part-time teacher, we had a lady who owned a bar and restaurant, we had an electrician, we had a farmer, and we had a remote worker for the World Health Organization. So people that were representative of typical society. We decided that what we would actually do for these guys would provide them the full range of technologies at their properties. So they got an electric vehicle, they got an EV charger, they got solar on their roof, they got an air source heat pump, they got a small residential scale battery within their home. And for a few of these guys, where we needed to, we actually did a deep retrofit of their properties to make sure that the air source heat pump worked. We also selected 10 other people across the peninsula that we provided electric vehicles to. So we gave them a lease, we actually leased electric vehicles, and we gave them a car for a year to actually, on the one hand, to understand EV charging, what that meant on the network, but also to learn in terms of driving behaviors and patterns, distances, and all that great stuff. And we have some really interesting learnings from that. We also selected another 20 people and we provided them with solar PV. And really, they were the guys that we wanted to work with us on our peer-to-peer trial. So unfortunately, we didn't do a huge amount with those guys as the project progressed because we had de-scoped the peer-to-peer trial part of it. But there's lots of learnings in terms of solar PV and usage and the benefits of that to people. And we have a good associated story with that I'll come to. And then finally, for 5 of the people that we have provided the electric vehicles to, about 3/4 of the way through the EV trial as such year, we actually swapped out the EV chargers and gave them vehicle to grid chargers because we wanted to test the impact of basically taking power from the cars, putting it through the home and out onto the network to see the value of that. And then there were 2 additional electric vehicles that we made available to people on the kind of a month or 2-month basis so they could further experience driving in their locality. So Kieran, you can take over from here.
Perfect, thanks Fergal. I suppose as Fergal mentioned earlier, I suppose as we become more reliant on electricity for heating and transport, I suppose it's really, really important that that electricity supply is probably more reliable than ever before. ESB Networks also has incentives from the regulator around minimizing customer minutes lost for customers and the number of interruptions that they have each year. I suppose in terms of the actions then we took around the network reliability, really, I suppose Dingle is a pretty rugged area. There's a lot of our medium voltage network over mountains and hills and fairly difficult to access. And this drone image gives an example of one line that goes over the top of this hill. I suppose when you have a fault on these areas, they can be slow and difficult to access and problematic to find the fault. So we were trialing technologies like smart fault passage indicators at various locations along the network that were able to send back signals and measurements from different points around the network to help us pinpoint what sections of the network the fault occurred on. Now, as it transpired, while Dingle is a very exposed, rugged area, there's not an awful lot of trees, and which is probably one of the main causes of faults on our network. So we actually didn't get as many permanent faults on the network as we would have liked to be able to fully prove these technologies in the Dingle area. And subsequently, they've been removed from the network in Dingle and will be redeployed elsewhere for, I suppose, to study them further and understand their performance. Another technology that we deployed in Dingle was single phase reclosers. And the real benefit of these devices are on our single phase networks where we have non-permanent faults. So things like the 2 conductors clashing together, a branch hitting the conductors, a bird strike, any of these sorts of non-permanent faults where typically the fuses would blow and our customers could be out for anything up to a couple of hours. Where we have these single phase reclosers, the devices will trip when they see the fault, and then after a small amount of time, around a second or so, they'll reclose, and if the fault is gone, those customers will be re-energized and be on supply. However, if the fault is permanent, like a line on the ground or something like that, the devices will trip open and stay open then until the repair crews arrive and fix it. But we had one example down, I suppose, east of Dingle, where we had one of these devices with 76 customers connected downstream, circled there in red. And what actually happened was there was a lightning storm, and on the diagram in the bottom right, you'll see all the circled lightning strikes from that were taken from the internet. And what we would seen was then as well damage reported by customers at a point on the network. And from the parameters that were sent into our SCADA system, we were able to see the device operate. So it picked up the fault, it opened and disconnected the fault, and then the fault had cleared, and those customers, the recloser reclosed, and the customers were brought back onto supply. Now, in terms of customer minutes lost, that was a significant saving for ESB Networks, but more importantly for all the customers, most of them would hardly have really noticed that particular outage. I suppose all the things that we were doing then on the network reliability space was, at the moment, we have very limited visibility of what's happening on our medium voltage and especially on our low voltage networks. So we've deployed just over 30 transformer monitors where we're able to measure power, voltage and current at different points along the network. But that also really enabled us then in our customer flexibility trials to assess the impact that these technologies were having on the network. So at a transformer level, we could see when EV chargers would kick in and cars would start charging. We could see the impacts of solar, where there was excess solar in a home being sent out of the home out onto the network and up through the transformer. We had minute by minute measurements to be able to assess the impact of all of those things. We also had one installed in a housing estate within Dingle town, and it was a housing estate where there was approximately 20 houses and all had air source heat pumps. One of the interesting things that we noticed was every Sunday morning at 2 a.m. Or every Saturday night, Sunday morning at 2 a.m., there was a large spike in the electrical load. And what it was down to really was the heat cycle that a heat pump was going through. And we're assuming that the majority of the heat pumps in that housing estate were all left on, we'll say, default settings and all configured to go through their heat cycle at approximately the same time. And I suppose what we'd be looking for in future is that if a little bit of coordination could be done, that, you know, I suppose these cycles in the 20 homes could be spread across several hours, across the night, and even across different days of the week. And in that case, then these large spikes in demand would essentially disappear. Fergal.
Thanks, Kieran. So I mentioned that we have this concept of the active energy citizen, individuals who, through their actions, could have a positive impact on the energy system. And in our interest, we were really only interested in the local electricity network. So when we did lots of things, which I'll come to in a second, but when we looked back at it, we said, Geaney, when we looked at all these different initiatives that we had, we could bundle them into 3 different areas. One which was around engaging people on the low carbon transformation message and getting them to be willing to accept technologies into their properties and to get involved in trials, but to share their learnings across the community. So that was lots of stuff that we did from an engagement perspective. But what we also wanted to do was, we realized that our project had a limited time frame. So 3 years is really the duration of our trials and initiatives that were happening, that we were leading. But what we wanted to do was make sure that when the project finished, that it wasn't a case of everything stopped. So we wanted to empower people across the community so that they could continue to do the good work that was carried out as the project was progressing. So we had lots of initiatives that I'll come to in a second about how we actually empowered them. But then again, we wanted to understand, well, was this successful? Could any of the learnings that we came to down in Dingle, could they be used elsewhere across Ireland or across society elsewhere? So we had a number of different evaluation initiatives and exercises that we carried out. So you just go to the next slide, Kieran. So if you think of who we actually engaged with, and this kind of really grew as the project kind of progressed over time. So initially, the first thing that we did is we said, well, we need to build a position of trust on the Dingle Peninsula, because a lot of people are very distrusting of large organizations at a local community level. So they obviously, there's almost a sense that the large organization might be out to further its gains, whereas we just wanted to learn by working with the community down in Dingle. So the first thing we did is we established a partnership with the Dingle Hub, down there. So they do loads and loads of things around kind of trying to develop sustainable employment in the community and trying to drive the low carbon agenda. So by working together with the Dingle Hub, we were actually trusted then right from the start, and that helped us actually open doors across the peninsula. I mentioned earlier on that one of the first things that we did is we recruited 5 Dingle ambassadors, as we call them, people that will be advocates for everything that we were doing. And those guys, through working with us and through working with the Dingle Hub, started spreading the message about everything that we were actually trying to achieve and trying to learn for the whole community right throughout the whole project. And then as we engaged with other trial participants, whether it was the solar PV people or the people that we gave the electric vehicles to, we had more and more people that started integrating and kind of working with us. And then we had lots of information sessions, whether it was physical on the peninsula at the start of the project or more virtual when COVID hit. We actually got our reach out and our message out to lots and lots more people across the wider Dingle community and beyond that at a national level. So that was really, over time, we actually grew and grew the scope of our engagement across society really on the project. And today is part of that as well. So the next slide there now. So I suppose initially when we conceived the project, what we wanted to do was to develop clusters of technologies in different parts. But, you know, as we started engaging with people, you know, it wasn't possible to get a number of different people in particular locations or particular clusters of people to actually sign up to take part in the trial. Maybe there was an element of skepticism at the start, but over time, as the project progressed, people became more comfortable with us. And certainly after we recruited the 5 ambassadors initially, there was more and more people more willing to work with us. But as we were going through that whole recruitment process, we said, never mind the clusters of technology, let's figure out, can we actually have a spread of participation right across the peninsula so that we could share and socialize the learnings more effectively. And that's really what resulted. You can see from the map there of where people were located that we provide the different technologies to. The next slide, Kieran. So in terms of engagement, the very first thing we did was we appointed somebody to be a full-time community engagement manager, somebody who will be physically down on the peninsula for as much as possible, somebody who would be approachable. So if people had concerns about what we were doing, had lots of questions, there was some place where they could go. Our partnership with the Dingle Hub actually gave us a base as well for the project down there. So we had a place where people could come in and chat to our engagement manager, and that just got people really comfortable with what we were actually doing. I mentioned getting our ambassador program kicked off, but really that was an incentivized trial. Like ESB Networks funded the technologies that we rolled out. So we paid for the solar PV in the homes, we paid for the air source heat pumps, the EV chargers, we leased the electric vehicles, we even covered the cost of deep retrofits at some of the properties. But it wasn't just a one-way handout. We expected the people that were working with us to share their messages, to be really, really open and to engage further across the peninsula. And that's actually what happened over time. People got very comfortable telling their stories. And actually that was a key learning, is that people trust people within their local areas. So if you have somebody really confident in sharing their message, getting the message out there about their experience, other people in the locality are possibly more likely to listen to them than just a sales pitch from a technology seller or something like that. So we also established or got involved in a number of different local steering groups across the peninsula. One of them was Geaney 2030 or Dingle 2030 initiative. So they were looking at low carbon transition, but not just from energy. They were looking at it from an agriculture perspective, from the tourism and trade perspective, from fisheries, from the wider transport agenda. So those guys, working with those guys, helped actually open up many more doors for us in terms of who we'd engage with, access to policymakers and things like that. As I mentioned, we had lots of presence at local events. Initially, we had this lovely little marquee tent with our branding on it. So Dingle has festivals every week or every couple of weeks, and we would have had a presence at those, again, to just tell people what we were actually doing and explain the whole reason behind the whole program. We had various competitions that we ran through schools and things like that. And then we worked very closely with the local media, whether it was Kerry's Eye or the, forget the other newspaper down there at this moment. Apologies if anybody's listened that's involved in that. But we worked with the local media and the local radio station down in Dingle as well, or across Kerry, to actually share the message about what we were doing. And if any concerns kind of emerged across the community, we were very fast to address them. That really got everybody on side with us. So just go to the next slide there. So I mentioned we wanted to actually empower people and get people comfortable with taking on the initiatives and continuing them when our project finished. And one of the great things with the ambassadors that we chose, they were all really keen to share the messages. They got so comfortable and got so professional really in terms of their delivery that they participated in so many different webinars. They were involved in every webinar that we had. We nearly had one of the ambassadors on it to actually share their experience. We had them involved in some of the Radio Kerry broadcasts as well. But they also had their own initiatives under the Dingle 2030 kind of program of activities, where again, they were sharing everything that was happening and what the whole program was about. So lots and lots of engagement in that regard. I mentioned the webinars and the online series. We did so many of those webinars as well. Radio Kerry were really, really helpful to us and really helped us get our message out there to a much wider audience than just on the Dingle Peninsula. And then the Dingle 2030 program had lots of initiatives itself. It ran a number of different energy clinics where it people kind of approached an independent expert in kind of low carbon transition and just making your home more energy efficient, all this sort of thing. And they were able to be given advice in terms of the first steps they should take to kind of help them along that journey. So there was lots of things in that space. But working together with the Kerry Education and Training Board, there was also an energy mentoring program established. And what that program did is it equipped 12 people across the peninsula with enough skills and knowledge so that they could have a conversation or hold a conversation either in a family group or in the pub, and basically be able to explain to people, oh, this is what a heat pump is, this is how it works, this is how you apply for SEAI grants on whatever it is, an EV charger or a solar panel installation. So we were really building up the knowledge bank across the community of everything that was happening. And that actually became so effective that instead of us dealing with queries that we were getting from individuals, we started pushing the queries out to some of these energy mentors so that they would actually have experience then of seeing real life queries that were coming in across the community and dealing with them. So there was lots and lots of different things we did in that regard. And as the project progressed then, and I suppose impacted a little bit by COVID, we had lots and lots of different stakeholder visits down to Dingle between, I suppose, October and December of 2022 primarily, where we brought groups of people down, policymakers, people across the industry who were interested in what we were actually doing. We brought them to the homes of the ambassadors where the ambassadors could tell their story. We gave a demonstration of some of the technologies that we'd installed, but it was primarily the ambassadors telling their story, what the technology meant to them in their day-to-day lives, and any concerns they had or the impacts of the installation of different technologies or whatever. So it was a warts and all approach that was shared, and that was really positive. So then the final thing that we wanted to do is we actually wanted to understand whether we were successful in some of the programs that we rolled out. And in particular, we wanted to see whether initiatives like the Dingle Ambassador program were effective and whether they could be duplicated elsewhere. So we engaged with MARI, the social research team out of MARI down at UCC, and those guys engaged well over the course of a year with different people on the project to understand what their feelings were, how their feelings were evolving, both in terms of the people that were actively taking part in our trials, but also other people across the community, different surveys that they did. And the MARI guys produced a very detailed report on the effectiveness of our ambassador program and our EV trial that Kieran will come to now in a second. But they also produced lots of other reports. I think we have another slide here, Kieran, yeah. Other reports that they produced themselves as part of the Dingle 2030 initiative, in terms of diffusion of technologies, in terms of just the transition towards low carbon right across the community. And there's a wealth of information there that if ever you have an evening where you're not too busy, there's lots of great reports to actually read there. So from a success perspective, the project down in Dingle was really successful in that regard in terms of active energy citizen and diffusion of technologies and behaviours and all that. But we've been asked since then, what would our recommendations be for other communities? Could other communities do this? Like ESB Networks isn't going to do another Dingle project. We think we've learned as much as we're likely to learn from that sort of initiative. But there's essentially an architecture or an infrastructure across the country that could enable other communities to do something similar. So for example, we've lots of the SEAI energy communities. We've a number of other digital hubs or connected hubs right across the community. And then on top of that, you could have the local authorities who all have kind of an objective to lead low carbon initiatives in their own communities. And maybe by layering some of these kind of bodies on top of each other and getting them to collaborate, there could be the opportunity for other initiatives similar to what we did in Dingle to kickstart in other communities right across the country. So that's kind of where we're going with our recommendations in terms of how others could follow on from the work that we did down in Dingle in that regard. So what's next, Kieran? So I'll hand over to you now, Kieran, to talk about flexibility.
Yeah, perfect. Thanks, Fergal. So what we mean by customer flexibility is really about reducing demand on the network by using a customer's own ability to change their usage patterns, either by reducing how much they're consuming or by switching on generation or using energy storage that they may have in their home in the form of a battery or connected vehicle. And I suppose several of the technologies that we deployed in Dingle were controlled to provide those types of services. So before we go any further, it's important sort of to understand the technology and the interconnections between them that we installed in Dingle. So I suppose the first thing, while I suppose the smart meters are being rolled out around the country at the moment, at this point during the Dingle project, there was no smart meters installed on the Dingle Peninsula, but we had remote read interval meters where we were able to dial the meter and receive back energy data from them. But they were an older unit used previously in the 2010 smart meter pilot, but they didn't really give any real-time information. So to do anything smart with them was quite difficult. So instead, what we'd done, we installed some very low-cost energy monitoring sensors that would monitor the output of, say, the solar PV panels, and also monitor then basically at the meter point if a house was consuming or exporting energy out onto the grid. Separately, then we had two different types of chargers, as Fergal mentioned. One was vehicle to grid, and the other was a regular 7 kilowatt or 32 amp EV charger. Both units were from a company called Wallbox Chargers. We had a Sona and hybrid battery energy storage system then, which for our ambassadors, the 5 ambassadors, their existing solar PV was rewired and integrated into that battery energy storage system. They also had all 5 Mitsubishi electric heat pumps. And I suppose one of the important things then to be able to monitor and control all of these different technologies, we went out and we sourced a service from a company called Greencom Networks. And what they did was they had a gateway device, quite a low cost device that could be connected into the broadband router at each of the participants' homes. And there were software drivers then that they had developed to be able to communicate with all of these different technologies, receive the measurements and be able to issue control instructions. So we could pause or suspend EV charging, and we could start and stop the charging and discharging of the battery and alter the set points for it. We could instruct the heat pump to turn off or to force the hot water on in various circumstances. And that gateway was connected to the customer's own Wi-Fi modem or router, and from there then it communicated out to the internet, where Greencom had several cloud-based servers to collect all of the data that was coming from each of the participant homes. Having all the data centrally then, I suppose, enabled Greencom to provide a customer app to all of the participating customers. And on that app, they could see their live energy usage from the various assets that we were monitoring and their overall household consumption or generation and maybe potentially spill out onto the network. They were also able to use that app then to trend that data over time and produce various reports to see how they were doing on a daily, weekly, monthly basis. Having, I suppose, a suite of online services hosted by Greencom as well, ESB Networks had a interface to that to be able to provide us with historical data. It also allowed us to send instructions and commands into the Greencom system that could be passed out to the various sites. I've shown the Greencom system here as a brain as well because it performed another very important function, and that was it ran an optimization at each household so that it would, I suppose, it was to save the customers the most amount of money. So it took things like weather data to understand what the likely solar output would be for the following days. It learned based on the customer's energy habits and usage how much they were likely to need on a day-by-day basis, and it continuously reran an optimization to try and operate the devices at the best time possible and to save the customers the most amount of money. And I suppose with that in mind, the majority of the customers were on a day and night tariff. So the GreenCom system was trying to move some of the larger loads to the nighttime period. So with the technology in place, we wanted to run 3 different demand response schemes. The first really was to be time-based, and what we were trying to achieve here was to move certain demand away from peak times of the day. So generally between 5 and 7 in the evening. And if we could do that, then there was the potential where you could accommodate extra demand without, I suppose, immediate need for typical network reinforcements. The second scenario that we wanted to try and run then was an evolution of the first one, but rather than it being based on specific times a day, we wanted the system to be responsive to a more variable input. And in our case, we selected a kind of a fictitious price that we sent into the system. And I suppose really what we were trying to understand here was the controllers that were employed and the algorithms within the GreenCom networks platform, were they able to, I suppose, keep up with the pace of change and the differing information that was getting on a day-by-day basis, and continually optimize the car charging, the battery charging, the heat pump water heating, and those sorts of services in line with the different pricing information it was getting. The third scenario then was where there could be a potential issue on the grid. We've a shortage of generation. We've had a generator tripping or an interconnector tripping, or potentially down the line there's an issue in a more localized part of the network, and we need to reduce demand in a specific area. So the idea would be that we could send an instruction to specific or all households on the trial and have them reduce discretionary loads or demand, and supplement it then with energy storage where they might have batteries installed, or where vehicle to grid chargers are installed and have compatible vehicles connected. So I suppose in terms of visually how that would look, so the first scenario in the block type profile, it's very repetitive, continuously same profile every day. And in the light blue there, we see energy consumption across all the households. And I'll elaborate further on that when we get into some of the more detailed graphs. On the scenario 2, then we see I suppose the granularity of the data that we were given it on a day-by-day basis, with basically a different price for every hour during the day. And again, in the lighter blue, we see the overall energy consumption, and I've further graphs on that to go into further detail. And then the final one at the bottom here, the third scenario, is basically the light purple line here is where we switch off and then on for a short period of time, and try and get demand to reduce for that period. I suppose in terms of a kind of a flow, to activate both scenarios, the first 2 scenarios, whether it was the block type time-based one or the more variable dynamic one, we were developing notional or fictional pricing profiles that we were using and sending into the GreenCom brain, because the system was optimized to try and save the customers the most amount of money. If we could change what the pricing information was that it was getting, the system then should move the devices around in response to that, and that's exactly what happened. But it also took in weather forecast data and learn from the customer's own habits, how often they charge their car, what days they charged, how much did they use during the day when solar was at its peak, and things like that, and it continuously optimized a 24-hour schedule for the various assets that were under its control. It was sent to the gateway at each property, and the gateway then was able to issue the instructions to the heat pump, the battery system, and the relevant car chargers. So to go into some more detail on the first scenario, the time-based scheduling, I suppose that the same tariff was provided to all sites. High price periods were in the profile for the morning and evening peaks, and then we had an incentivized low price during the middle of the night. What we'd seen was the optimization was successful in aligning the various loads with the lowest price periods, but what we found was that there was actually minimal demand reduction achieved during, I suppose, the peak times. And one of the main reasons for that was one of the largest loads that we were controlling was the EV charging, and basically the EV chargers, the EVs weren't charging during either of those peaks. On the top right hand corner over here, what we can see is that from the heat pump water heating, we can see a large spike in energy usage in line with the lowest price period, where we were able to force the hot water on at the 5 properties. And I suppose essentially save money at other and for the customers, and prevent certain amounts of load at other times of the day. Now, as the households used hot water, as the day went on, various energy was used then to replenish those tanks and reheat them back to their set point temperatures. What we see in terms of the battery systems, the light blue colors here is battery charging and the dark navy color is battery discharging. And we see that the charging periods occur in line with the lowest price periods, and again the systems discharge during the morning and evening peaks, with a small amount of recharge during the day from the connected solar panels. At the bottom, then we have the EV charging. On the left is the vehicle to grid locations, and on the right then is the other 10 EV sites. And I suppose what we found with this part of the trial was that while it looks like EV charging is being driven by the technology and the system, in actual fact, the main factor driving EV charging behavior was the real supplier tariffs and the cost of energy that the customers were exposed to. And I suppose they were very, very keen to maximize the savings of having an EV. So many of them didn't plug in their cars till 10, 11 o'clock at night. And I suppose when there was an override facility as well, that if customers needed to charge outside of the optimal schedule, they had an option to do so. The problem with that was that many customers were anxious around leaving a third-party system control their charging, and so they left on the override, and it limited, I suppose, our ability to manage the charging in the way that we had hoped. And I suppose, while maybe not as successful as we would have liked, a very, very key learning for ESB Networks as we kind of move forward with the National Networks Local Connections Programme and trying to manage customer demand going into the future. On the second scenario then, which was the more dynamic price-based solution, what we'd found again was the optimization did successfully move the controllable loads and align energy consumption with the lowest price periods. And I suppose the battery system was the best performing piece of kit that we had in respect to that. In this plot here where the cursor is, the light blue color shows where we had the lowest price that we were getting the battery systems charging, and then where we had the highest price, the dark navy color, we had the battery systems discharging. Now I'll go into a little bit further detail on the next slide, I suppose, around the battery systems and their ability to change their behavior day on day as those profiles changed. On the bottom, again, we have the two different types of EV charging. And as before, I suppose the charging happened primarily between 10, 11 o'clock at night and 7 or 8 o'clock in the morning, again, driven by the supplier tariffs that customers had. Going in then to the battery system in a little bit more detail. So the different graphs here show 5 consecutive days. The orange line is the profile for each of the different days. Again, the light blue is charging and the dark navy is discharging. And as we go from the 18th of December to the 19th of December, we can see the charging happening earlier in the night, and then we see a different profile for the energy being discharged in the evening. And the profile, I suppose, changes in shape due to the intensity and the sort of the duration of the pricing peak. And I suppose in some cases it's interesting to observe where on the 21st of December, for example, some of the battery systems recharged again ahead of a sharp increase in price a couple of hours later. So it was interesting to see how the algorithms and the intelligence in this system adapted day on day to the changing pricing information and operated the battery, I suppose, in the most economic interests of the customer. The third scenario then was akin to a big red button. We have an issue on the grid and we need to reduce demand in a particular area. So we'd send an instruction from ESB Networks through to the GreenCom system. This could be akin to an aggregator or a third-party platform. And then from there, it was sent to the various specified locations or gateways, and then it controlled the various assets. The command that we were able to send, we were able to specify specific households or all households, but as well as that, we were also able to specify a duration for the test to last. And one of the reasons for doing that was that it started a timer at each of the locations. So if it was a 10-minute test, the systems weren't relying on getting a stop command at the end of those 10 minutes. In case of any communications issues or failures, the systems would revert to their normal mode of operation at the end of that 10-minute timer. In terms of some of the outputs then, from the battery system, we can see when we get the command to go from 1 to 0 here, then the battery systems go to basically full discharge for the duration of the test, and then revert back to their previous mode of operation, whatever the optimization scheme had scheduled for that particular day. Similarly, on the top right, we have the heat pumps. There is a little bit of a lag with the turning off and turning on of the heat pump, mainly due to the data sampling that the API that we were leveraging from Mitsubishi Electric. There was a couple of minutes before it would pick up on a command, but even still, it shows the potential, if scaled up, that we could turn off heat pumps en masse to be able to reduce demand if required. On the bottom left, then, we have the V2G locations. And for this particular test, we had 5 different locations donated by the different colors. When the command is received, the charging is suspended, and then 4 of the locations are connected. 1 location, there's no EV present, but the locations then, the chargers start to discharge. There's a certain ramp rate, so it takes around 5 minutes to reach their maximum discharge, and then it lasts for the duration of the test, and then they go back to their previous mode of operation, whether they were charging or not. On the bottom right, we have the regular EV chargers, and again, we see 2 locations, green and purple, charging at the time of the command. And when it's received, they switch off for the duration and then go back charging at the end. So to look at the V2G in a little bit more detail, so on the 2nd of December, from 10 a.m. to 10 a.m. on the 3rd, we have energy consumption at each of the properties. So we have 5 V2G sites. So showing everything above the 0 axis is power imported to the houses from the grid, and then anything below the 0 axis is where these households exported power back out onto the grid. So at the time of the 15-minute demand response test, there was a combined demand of around 21 or 22 kilowatts across the different sites. So at 22:05, we sent an instruction to these 5 locations for a 15-minute demand response test. And within 1 minute, the charging at these sites had suspended. What we'd seen was that one of the 5 sites had no EV connected, or if it was present, if it was at the home, it wasn't connected. One of the sites was connected but had not been charging, either due to it being fully charged or waiting to start on a schedule, maybe at 11 p.m. or at midnight. For 3 of the 5 sites, they were currently charging their EV. The charging suspended, and then the 4 connected vehicles all start to discharge energy. So by 22:10, then within 4 or 5 minutes, the 4 sites had reached their maximum discharge capability from the vehicles. And then from 22:10 to 22:20, the exported power to the grid varies based on how much I suppose the household is consuming, and we see the site here in red. It's consumption varying, altering how much was going out onto the grid. By 22:21, then we had the end of our test, and the 3 locations that were charging resumed charging. But what's really important, I suppose, to note here was the net change in power flow across these sites. So we had between 33 and 35 kilowatt net impact on the grid across from the 5 locations where we had V2G. I suppose that's really important in terms of the potential for this technology going forward and the capability that it can provide, even compared to the domestic battery systems, which typically have smaller inverter ratings and definitely a much lower energy capacity. Another example then of a demand response test was at one of our ambassador homes. And on the screen, so on the top right, we have from the transformer monitors that I mentioned earlier, we can see the power flow at the transformer, where there are approximately 6 customers connected. So we can see the EV charger coming on and load going from around 1 kilowatt to just over 8 kilowatts. On the graphic itself, we can see this is similar to the app that the customers would have had in their phone or on their laptop. We can see parameters for how much was coming in from the grid in terms of grid supply. During the animation, we'll see that that goes green where energy is being exported or being fed into the grid. We can see what the power output of the solar panels is. We can see whether the battery is charging and its power output and the state of charge of the battery. We also see the status of the EV charger and the amount of power it's consuming. We have the status of the heat pump, and then all other non-measured loads are captured under appliances. So the next animation is sped up quite a lot for the purpose of the presentation. But what we will see is we'll see an instruction issued. We'll see that there's a step down in demand at a transformer level. We'll see that the EV charger will turn off and the grid supply will go to being grid feed in, 2.3 kilowatts being fed in as the battery is now discharging 2.4 kilowatts. We can see the impact that that's having on the transformer, as that 2.4 kilowatts is actually enough to send power up through the transformer in the opposite direction. So it's meeting the needs of the other 4 or 5 customers on that transformer during that period as well. At the end of the 10-minute test then, the systems go back to normal. The EV charger is now back at 7 kilowatts, and we have 8.5 kilowatts coming in from the grid again to this household. We see the impact of that on the transformer. I suppose no different to the previous example, the capability here to control these types of technologies is there. The technologies can do it. I suppose there are certain challenges around integration of different technology types from different vendors, but those things can be overcome. Communications is, I suppose, challenging, and we'd had many issues on the project with both broadband and cellular connections to each of the homes, but also even from the broadband routers in each home out to some of these different assets, like the EV charger being connected by Wi-Fi and located on an external wall. So those are issues that are challenging, but again can be overcome. I suppose the response is quite powerful if used and leveraged in the right way. To move on briefly then to the electric vehicle trial. So what we'd found was we had 17 vehicles, 15 of them in use full-time by people on the peninsula and 2 on a shared basis. Over the course of the 1-year period, they covered over 362,000 kilometers. We had over 2,100 charging sessions completed at customer homes and over 59 megawatt hours of charging. But one of the things we found was very, very quickly confidence grew in I suppose, electric motoring. We had several users doing over 3,000 kilometers a month, some even doing more than 1,000 kilometers a week. And some of the biggest numbers we'd seen was 786 kilometers a single day, over 1,900 kilometers in a month, and over 4,500 kilometers in a month. And I suppose while the impact of EV charging was significant, the demand reduction schemes and the capability of vehicle to grid demonstrated that there's a lot of potential for flexibility services and for these types of things potentially to be managed going forward. So with all of those vehicles and over the full year and telemetry from each of the vehicles, we had quite a lot of data. What we found was that for many of the modern EVs available on the market today, a lot of them have a range of 330, 340 kilometers or more, and that really proved suitable for rural areas like Dingle, where the majority of charging was actually done at home. 95% of the time, basically. So we have 365 days with 17 EVs, and all the dots on the graph demonstrate the amount of kilometers that each vehicle did for each day of the year. And 95% of the time they traveled less than 200 kilometers. And it was only about 0.4% did any of them travel more than 400 kilometers. And the majority of the vehicles we had on the trial were Hyundai Konas with a range in excess of 400 kilometers. So it really showed the suitability for those vehicles in those types of locations. And I suppose it's important going forward, as was mentioned even last week during the launch of ESB's new strategy. Minister Eamon Ryan, also noted, or it was Professor John Fitzgerald noted that rural travelers drive further than urban. So EVs are certainly suited to decarbonising rural journeys. One of the things we also wanted to look at was the impact of V2G on the voltage, because it has quite a capability to consume or inject power onto the network. And with that, we wanted to study its impact on the voltage, particularly on areas on the west of Dingle, where the network is typically quite challenged for voltage. So what we had seen in some cases was when it was exporting at full capability, voltages up around 251, 248 in that region in some of the locations. And in other areas we had seen where during charging the voltage dipping below 210, even dipping below 200 for small periods of time. So I suppose from an ESB Networks perspective, that was a really valuable learning again, because we need to understand that as these technologies become more stream, what that could mean for the network and how settings might need to be adjusted to manage those impacts. Fergal.
Thanks, Kieran. That's really great, really detailed. So we did publish a couple of reports. I mentioned earlier on that we published a report on our peer-to-peer trial, or the trial that we didn't go ahead with, in terms of the learnings from that, and there were a few. But we also published two other detailed reports, a report on active energy citizenship and customer engagement, and we also linked in that a link to the Mara report as well, which is their own independent verification of what we were actually doing on there and the effectiveness of it. And then we have a third very, very detailed report on the flexibility trial that Kieran has outlined there. So there's lots of really good learnings there if people want to read them. But one thing we didn't really talk about there, and we didn't produce a slide on it, was the learnings that we got from working with the individuals on the trial, and essentially the human behavior learnings which impacted in particular the flexibility trial and the EV trial to a certain extent. Like, there were certain things that we learned very early on. Like, we could have done a lot of this in terms of a lab trial, a technical trial, that we would have been controlling devices within a lab environment, and that would have provided a certain amount of information to us. But it's really only when you interact with people and you see how people use technologies, you really get a feel of what this would be like across society. And there were certain things very early on that we learned. For example, when we gave out the EVs and we were looking at the pattern of charging that people had, people initially started following the same pattern of charging their EVs as they would have had for, say, filling up their diesel or their petrol car. So maybe once a week or once every 2 weeks, they'd give it a big fill. And when we looked at that, we said, well, this isn't really good for us, and it's probably not really good for you. From a flexibility perspective, if it was taking them 6 or 7 hours to charge their car, but then we didn't have much scope for moving that load around at night time. So we needed to kind of get people to be a little bit to charge in a different kind of periodicity, so that we could have smaller blocks of charging that we could move around per night. But also, when you thought about it, if somebody was waiting, say, maybe a week or 10 days to charge their car, if there was a problem on the network and the supply went down, well, they'd be a little bit snookered. So having a different approach to charging, where maybe you plugged in every night and you charge for an hour or 45 minutes, it probably meant that you had a car that was nearly at full range the whole time. So if there was an outage on the network, you weren't impacted. But also, it's much easier for us to move an hour block of charging throughout the night. It gives us essentially 6 or 7 blocks that we can move it into. So there was learnings like that. But even kind of other learnings that came to us in terms of how people interacted with the technologies at home. Like, as Kieran said, we put the gateway in the home. We had things linked up to their own routers and their own Wi-Fi. But people had habits, they had energy saving habits in the home. And at night time, if they saw a standby device on, they were turning it off. They were turning off the isolator switches outside the home at the EV charger and things like that. They were disconnecting the router. So even when we were trying to send signals to the home, it couldn't get the last couple of yards to the device. So lots of key things like that. Kieran mentioned all the communication channel challenges that we had. you know, when we were primarily using Wi-Fi within the home to connect to devices, because we didn't want to be mandating or suggesting a wired approach to connecting devices up. We wanted to leverage technologies that would exist in people's homes. But, you know, there was lots of problems there based on the fabric of homes as well. Very difficult to get a signal bounced around people's homes, even with Wi-Fi repeater stations and things like that we rolled out. So lots and lots of different technical challenges like that we had. Kieran, I'm sure there was some other human behavior learnings as well that we had that are probably coming to mind during the flexibility trial.
Yeah, I suppose as people used energy as well in different ways during the day, the third demand response test where we would send an instruction, and I suppose in some cases we would get a discharge from the battery energy storage systems, depending how people used energy during the day up to that point. It'll have an impact on what energy was actually left in those batteries. It would be impacted by things like the amount of solar that was produced during the day for recharging the battery. And I suppose if we sent an instruction at maybe 8 o'clock in the evening, just after the evening peak where people might have been consuming energy, cooking dinner, things like that, the battery could very well be almost empty and we'd get very little response. But if we were to send an instruction at 3 o'clock in the middle of the day, the chances are we would get the full 2.4 kilowatt export from the battery. So people's behaviors and the way they use their energy also had impacts from that perspective. Also other things as well, like the vehicle to grid we had seen in the example there, and that was a test that we had given an instruction and told them about to be there and be connected. We still didn't end up getting 100% of the full capability because one of the cars actually wasn't connected to the charger at the time of the instruction. So trying to understand and estimate that variability going forward is going to be difficult, but key to trying to harness these services.
There was something else that came to mind as well. We ran a webinar series in December 2022, and it just coincided with one of the big storms. I forget the storm's name, Storm Barra, I think it was.
Yeah.
And the interesting thing was, so the Dingle Peninsula got fairly hammered, and there was a lot of network infrastructure that was down on the ground and things like that. So there was outages for up to 3 days for some people. But for the trial participants, for the ambassadors who had deep retrofits carried out of their properties, one of the things for them was they didn't even notice a reduction essentially in the temperature within their properties. So the insulation was proven that the insulation work that was carried out was really effective. Now, the other thing was they were asked questions on the webinar about, well, were you impacted in terms of not being able to charge your car and move around? Well, of course, they couldn't charge the car, but because of the fact that there was essentially a stop on activity on the peninsula because of the storm, they weren't going anywhere. So there were kind of learnings that we hadn't actually considered as part of the trial. And the timing of the storm was actually really, well, it was coincidence in terms of when we were delivering our webinar. It actually allowed that message to get out there that the fear of people transitioning to low carbon or electricity only was lessened to a degree, even during one of the worst times that you could imagine, you know. Yeah. So kind of that's as far as we got in terms of presentation. Over to yourselves now to ask us anything that you think you might like to know a little bit more about the trial. We'd be happy to answer. So I think that's the end of the recording now at this stage, and we'll do Q&A.